Could I ask all the speakers to put their videos and microphones on, please? That would be very helpful. And I'm just going to share some questions that we have. Bear with me a second, find the right screen. Yeah, I'll read them out for everybody's benefit. Bjorn, so the first one is, if gas phase air cleaning achieves good perceived air quality at lower ventilation rates, and as you suggested, CO2 controls need to be adjusted to support that, is there a chance that CO2 concentrations could rise to levels that have been reported to affect cognitive performance?
Yes, but the air cleaners we have seen now, it shouldn't be a problem. But if you have very efficient air cleaners, so the amount or required ventilation go even further down, you may be up at the 2000 level. It's still debated at which level you have cognitive performance. Does it start at 1600 or is it 2500? But that's something we are looking at. If you look at the European ISO standard, there is a recommendation there never to go below 4 liters per second per person of outside air. Mm-hmm. And that will in most cases take care also of the higher level CO2.
Okay, the next question was about the sort of main barriers or resistances that exist to the uptake of these gas phase air cleaning systems in existing buildings.
Well, I don't think there's the barrier. There's nothing against using gas phase air cleaning, and if you read the brochures from companies, they can do everything. They promise to be better air quality and so on. But that's because they have not been having the test that we think is necessary. Some technologies, for example, in absorption, using charcoal absorption, there we know there's no chemical reactions in the air cleaner. So that should not be any danger that they will deteriorate or make new substances. But if you use a chemical reaction, or if it's generated ozone that is not removed before it comes out in the space, there is a risk that it will go in a chemical reaction with some of the bioeffluents, and then you will have new substances which people feel is not very pleasant.
Right.
So that's some of the issues.
Okay, and one last question before I move on to some questions for Stephen. If you could say a few words about the considerations for air cleaning technologies and COVID-19 impact. I think you mentioned that it probably doesn't help, but are there any implications?
It depends. Some air cleaner using gas phase, but they also remove particles. And COVID-19 has to do also with particles, if you can remove that, so you also have that benefit. So that there is a possibility that you can have both.
Okay, thanks. So I'm going to move on.
ASHRAE and LIBA and the published guideline about air filtering the COVID-19 virus. So you can download freely from LIBA and ASHRAE guideline for COVID-19.
Thank you. I'm going to move on to questions about data-driven smart buildings now. And the first one's a fairly provocative question in a way. Given that a lot of energy waste is time-based, it's equipment operating when it shouldn't, what's the value in terms of energy saving, at least, of going beyond sort of straightforward analysis of smart meter data into the more sophisticated systems that are in data-driven smart buildings? Stephen, you're on mute.
I do like going back to the NREL study of the Smart Energy Analytics campaign, because it is so many buildings. You know, it is really quite statistically robust there, and they divided it into 3 different forms of energy savings. One was just around, yes, here's some energy meters. Let's trend them and see if we can identify how things are going. And you know, there was a relatively small but meaningful saving there. I think that was in the order of 2 to 3% or something. And then the number that I quoted before of 9%, that was for fault detection and diagnosis, which is exactly what sort of put there of you know, having dampers open in the middle of winter and summer and things like that, having coils fighting each other and the like. And then there's a third form, which is actually smart controls. And rather than having fixed set points, actually manipulating set points and things like that, hasn't been widely implemented, and things like model predictive control would fit into that for an additional source of energy savings. So yeah, there's a lot of opportunity there across a range of data-driven solutions. And yes, I think it's important to point out data-driven as a technique as opposed to rules-based. Rules, you follow a sort of set of principles, but data-driven, you're actually training your algorithms and learning what is an optimum as an approach.
Yeah. Okay. Yeah, I appreciate that. And the second question is, will it be possible to make all existing buildings data-driven smart buildings, or are there type, size, or other constraints that's going to limit the applications?
That's a very good question. So a new building, at least in principle, will pretty much have the connectivity as an intrinsic feature there. Existing buildings, often with legacy building management systems, it's pretty hard to actually break into the building management system. But you know, what I'm finding in my own work is that buildings do go through some kind of life cycle, and so when they're in their upgrade process, it would be normal for building owners to want to actually get some visibility of their data, and so they are asking for, you know, head-end replacement on their building management system with a gateway that enables the builder to hold for data. And you know, one of the things for us is to actually get these standardization into this so that we can go down to smaller and smaller buildings rather than just the large scale premium A-grade buildings in the CBD, to actually start to get down to smaller buildings.
Professor Akashi, anything to add to that from the Japanese experience?
Can you hear me?
Yes.
Yes. Thank you very much, Stephen. I agree with your comments, and from Japanese situation, I think the key word is upgrading. Usually, building performance, the maximum of the building performance is just after completion of the buildings. After that, the performance gradually decrease. But smart data-driven smart buildings, I think, can change the situation because according to the usage or according to the people comfortableness or energy consumption of the buildings, we can see the situation of the waste of the energy consumption. We can change the operation method, or we can develop application newly and install the buildings. and we can match the building situation to the current usage of the buildings. As a result, I expect the building performance will be getting higher compared to the before. So I think the keyword is upgrading in operation phase, normal time also.
Thank you. Well, we have had one more question come in for the gas phase air cleaning, but I'm going to leave that and beyond. Perhaps you might just pop a reply in the Q&A because we're close to finishing now, and I'd just like to ask Takao to come in and sum up and close.